In this demo, we want to implement a deep cloner. So let's start by creating a new Java project called demo, and I will create a package with the same name. Okay, we want to have a cloner class which will do a deep cloning. So that I would like to have a public static method which will return a generic type t, and this should clone an object. So we'd like to have a deep clone. Basically, we will think as follows. My object, I have to check the argument of the method. If it's a primitive value, then I will return it because it will be referenced by value. But if it's an object, then I will have to check and see either if it's a string or if it's an array or if it's implement clone, or if doesn't, I will have to clone it myself. So the idea would be that inside my object, if it's a complex object like a container, my object can contain sub-objects that have reference to the root of the container, to my object, which is the argument with what my clone method was invoked. So basically, what I'm trying to say is that I would have to keep a clone table as a key value reference between the original value of the object and the clone instance, so that in this way I will avoid going into loops and try to circularly clone objects with sub-objects that have reference to the primary object. So basically what I'm trying to say here is that the root method clone should call a new private method and pass a container as a map to collect the mapping between original objects and their clones. So I will do it simply like this. I will return the result of a clone method, passing the object as parameter, sorry for the spelling, and a hash map with key of type object and value of type object. I will create this method. It doesn't know to do that for me. That's not nice. Anyway, so I will add a new public static t method, which will be my clone method with a reference of type t and a map of object and object. Okay, so this should be my map. I will call this map clone table. So, and I will say that this should return null in the beginning, and this should be a private method. Okay, let's import this. Okay, so what I will do with this method, I will start cloning my object and passing a container to retain the mapping between initial object and his clone. Okay, having said and done that, let's focus on actual cloning of the object. What I have to do here, first of all, if my object is null, then I will return the object, because it makes no sense to clone a null value. Next, if the clone table already contains the key for this object, then I will return from the clone table the value corresponding to this object. That means that my object was already cloned, and this has to be cast to type T. Okay, so now if I have an object already cloned, then I just have to return the reference of the clone. Otherwise, if my object is not null and hasn't been already cloned, then I will have to start cloning this instance. And I will have to get the type of the object. Sorry, get type, get class, sorry. Yeah, so with this type, I will have to see if this is a primitive value. So if boolean class equals my type, or short class equals my type, or but before that, or byte class equals my type, okay, or even integer type, integer class equals my type, and so on. I will just flow.class equals my type, double.class equals type, okay, or character dot class equals my type. Then I will just return the object because it will be passed by value. Okay. If not, that's for sure I will have to create a new instance. This will be my clone initially null. In the end, I will return the clone, which has to be casted to T. Also, if the clone is not null, then I will have to store it in the clone table and put for the object the clone value before returning the value. Okay, and this is I have to say it before. That's for sure. Now it's null and this is a dead code, but it won't be in the end. Okay, so let's try and see if the object I'm trying to clone, it's a string. If it is a string, then I will have to copy and create a new string just to be able to change it to have different instances of that string. Okay, so I'll get the content of the string, data as an array of chars, and I will get my object as 2-char array. Okay, it's not able to identify, the ID is not able to identify that my object can be casted to string because I'm using the type and not the object to check the instance of. So I will have to convert to cast my object to a string and then to call to char array. Now I can set the clone to be with string copy value of this data. I will have a new clone created, a new copy. Okay, and now I can move forward and I'm able with this to clone string. Otherwise I'll have to check if the type is an array. So if it's array, then I will have to copy the value of the array. First of all, let's see what's the length of the array. and with array from Java lang reflect I can get the length of this object, which is an array. I'm able to create a copy of the array with array new instance, and the type of the component will be from the type of the array. I can call get component type to get the type of each element, and I know the length. And now I have to iterate through all the items that I have in the array and clone each item and set it in the new copy of the array. So I will have to go one by one with a for of index I less than length and with plus plus increment. And what I'm doing here, I'm creating a new instance, a new item in the array, which should be an object, by calling the clone method. I'd like to clone with array get. I can get from the object array the element on index I, and I'm calling a method to clone this recursively by passing the container to store the mappings between original objects and their clones. So now I'm cloning the item, but then I have to set the item in the new array. So I will call array set. The new array is the clone, the index is I, and the value is the item. And now I have already instantiating a new array, which is the clone, and I cloned each element in the array and set the clone to the new value of the object. This is how I can deal with an array. But then there are other type of objects that can be cloned. For instance, maybe my object is an instance of clonable. So if my object is an instance of clonable, then my object knows already how to clone itself. It's a pity the clone interface doesn't have a method like the one that I want to call the clone method, but this was implemented in Java like that, just not to be able to access it from outside the object. So what I have to do in order to invoke the clone method would be to search inside the object for the method with the name clone. So I will get method. I know this method, it's available, it's protected, it's available to be accessed. Actually, I would like to get the declared method. Even if it's not accessible, I will see it. Anyway, it depends. And I should have no parameter at all for this. So the list of types for parameters should be empty. This can throw an exception, and I have to deal with these exceptions. But you know what? I don't like to throw a bunch of exception here. Let's make a sign exception, and sorry for that. Let's randomly try multi-catch block, and throw a new clone exception with information from the inner exception, like the localized message and the exception itself. Now I'd like to create this class. I'd like to have a default serial for that. And of course, I will have to create the appropriate constructor inside the class. And the constructor should call the super to do the job. So it will call super with, this is not a right name for that. It's supposed to be the message and of course the exception. Okay, so now I have to throw this outside. Sorry for that. Okay, now it's throwing an exception in case of an error, in case of an checked exception inside. Okay, so after getting the reference to the method with the name clone, I'm able to actually invoke the method to create a clone. The method should be invoked on the target which is this object, and I'm not going to pass any objects in here. I suppose I'm able to do the same here. Okay, this can throw additional exceptions, but I'm not gonna handle those. I will instead throw them away from the method. Okay, so that's all I have to do in case the object is able to clone itself. But otherwise, if not, so my object is not a primary value, and it's not a string either, or an array, or it's not able to clone itself. Then I will have to see what are the fields of my object that need to be cloned, and I will have to clone each field at a time. But before that, I would like to get a constructor with no parameters from my type. Let's call this a constructor, and I will get a declared constructor with no arguments. The idea is that perhaps the object does have a constructor with no arguments, otherwise I'm not able to create a new instance of that type without knowing which constructor to call with which parameters. But perhaps the constructor is not public, it's not cannot be invoked because it's not accessible. So I will first check if it's accessible. If my constructor is accessible, and if it's not accessible, I will make it accessible. In the end, if it wasn't accessible, I have to let it as it was, unaccessible. But in between, I'd like to create the clone. So I will create this by calling new instance on the constructor, and now I have a brand new instance already created. And of course, my throws an instantiation exception, but this will be thrown away. Okay, I have created a copy of the object, but now I have to go through all the fields in my object. So I will get a list of fields with the type by getting the declared fields. Nice. Okay, next I will have to iterate through all the fields with an iterator called field. Sorry for that, which will actually go through all the fields. Now, misspelled. Okay, let me organize the imports. I imported by mistake one that I'm not using. Now, I have to check if my field is accessible. So if it's not accessible, because I need to get the value, I will have to make it accessible. So I'll set it, sorry, I'm not setting the value, but I'll set it to be accessible. Okay, in the end, the same story. If it wasn't accessible, let it as it was. In between, I need to get the value of the object, of the field. So I will call the field to get the value of this object for the current field. And I would like to set the value of the field to on the clone, on the reference that has been created, and the value should be obtained by cloning the original value using the same clone table. So the idea is I was getting the value of the field, I have to clone it. Don't forget to provide information about the objects already cloned. So if I have to clone a reference to a parent object that has been cloned before, I don't have to clone the reference again. And then after I cloned it, I just have to put the reference in here. Okay? And now, in the end, I'm returning the value of the clone. Okay, this one is catching a few exceptions from a bunch of exceptions. So I will, okay, that's not okay. I don't want to, I would like to add exception to existing catch. That's a huge list. That's why I said it's better to have a checked exception than to throw all this list. Okay, so now I have my support for cloning objects. Let's define a simple model in order to illustrate the fact, and then show that everything works. Okay, so I will like to create a list of numbers. Let's define an element in the list which will have an integer value of the number and a reference to the next element. I like to implement this list myself. I have all the support I need in the framework, but why don't you do it ourselves? Remember that we need to have at least a constructor with no parameters that will be invoked when creating the clone. So don't forget to put this. Otherwise, I might expect that my number will be created based on the value, and you can imagine what I'm doing here. I'm just storing the value. Okay, just for not going to have warnings about a constructor that is not called directly, I will call it, although it's the same. It does nothing. And of course, I will override the string just to be able to see the value which has to be cast to string. This list, I would like to keep it sorted. Let's say ascending. So basically, my list will know to append a new element to it. So let's add, you know what, I don't like to expose this public. Let's make it private to the list. Okay, and then make a static method to create the list of numbers. So I'd like to create, by calling the random number generator, I would like to create a list of numbers, and this list should be sorted ascending. Okay, so I will create here a method to append a value to the list. Okay, while keep it sorted. So what I have to do here is to compare the value inside my current element with the value that I want to add, and in case it is less than 0, the result of the comparison, this means that the current value it's less than the one that I want to add. So this means that the new value should be on the right side on the next chain from the current value. But then I have to check if my next reference is already created, because if it's created, I will ask my next element in the chain to add this value, so it will know how to keep it sorted, how to keep the list sorted. This means that my next element can be changed by calling it to append the value. Otherwise, if I have nothing on the next element side, then my next element will be a new number with this value. Okay, and in the end I will return this, because if my value is less than the one I want to append, in order to keep the list sorted ascendingly, this should be still the first element, and the value will be added on the next side. Otherwise, if it's 0 or greater than 0, then I will change the head of the list, because my value is greater than the one I want to add. So therefore I will have to create a new element in the list and place it on the left side of the list. So first of all, I will create a new number. Let's call it number, and this number will have the value that I need to append, and the number will have on the next side, which is the right side, my item, and I will return the number, which is actually now it's the new head of the list. That's easy as pie. It's not invoked by anyone right now, the method to append. Okay, in order to demonstrate how we are cloning and the fact that the clone can be changed without changing the original, I would like to add a method called adjust, which will actually add an integer value to all the elements in the list. That's very simple. I will just add this value to the current value, and if I have a next element, I will continue to adjust the next element with the same value. This will change the whole list, starting from the beginning. I would like to be able to consume the list, to visit the list, so I will implement a visit method, which will use a consumer of type over the numbers. This will be my consumer, and what we'll do with this consumer, I will ask the consumer to accept this, and if I have a next element which is not null, then I will put the next element to be visited by the consumer. Okay, so this is a simple way of visiting each element at a time, one by one, and going to all the elements in the list. Now I would like to have a static method to create a number, and I will say how many elements I'd like to have in the list and which is the maximum value of the numbers, because I will generate it randomly. So I'll create a random and a new random. Okay, and then I will have to create a head with a value, so I'll call the random to get the next integer with a bound to maximum. Now I'm creating a number, let's call it number, and this should be a new number with this value, and then I will iterate with an index to size -1, because I already created one element in the list, and of course I will get a new value by calling the same stuff here. Okay, and of course I will set the number to be the result of calling append with this value. So if the header changes, then I will have to change the number as well. In the end, I will return the header of the list. Okay, the head of the list, sorry. So now I'm able to create elements and show their value. Now I create a program, a console to display the result. And in here, that's quite easy. What I would like to have, first of all, let's maximize this. I will define a consumer over elements of type number. Let's call it consumer. And this can be defined using lambda expression. For instance, if I have an item, the instruction corresponding to the item will be to print the value of the item. So my consumer is able to access items from the list. Let's create a list of numbers, and I will call the class to create 3 elements, no greater than 10. Now I would like to display which is the original, which is the list that I've created. Okay, let's call this original just to make a distinction from the clone. So this will be the original, and I will ask the original to accept the consumer to visit it. Now let's create a new number that will be a clone. I will use the clone service, the cloner, to clone my original. Okay, this can throw an exception. I will just surround all the code that I've written up to now with a catch, and in the end, if I have a problem, I will just display the localized message of the exception. Now that I have a clone, let's display the clone. Or even better, let's adjust the clone by adding 10 to each element of it. Now, I would like to display which is the clone. And of course, I will ask the clone to accept my consumer for visiting it. So now I'm just calling this to do it. Okay, now I would like to see how the original is doing after adjusting the clone. So this should print the original as it was before. Now when I'm running this, as you can see, I've got a list of sorted numbers in an ascending way. Now, when I'm adjusting the clone, I add 10 to each element in the list, but the original was kept as it was before, so it was not changed. Okay, so basically that's a fancy way of showing it. Okay, I was trying just to work with data structures as well, but the point is that this clone, it's able to actually do a deep clone without having to change the implementation of the model, without having to make each element in the model clonable. Of course, the model is quite simple. However, it still requires to implement clone in order to do a deep clone of a list, which is not the case with what we did, because the cloner is able to do a deep clone. There is an issue here because I'm not able to clone elements of type int, for instance, the primitive types, because I'm just checking with their wrappers. Usually I should do this in a different way, and I can change it as well, just for the sake of the demo. Normally I should use boolean get declared class get declared field and ask for the field type to get its value. It is a static field, and this should be equals to type. I will have to do the same. This can throw an exception, and I've added this exception as well in here, and has to be added in here as well. So that's not what I wanted to do, but rather I would like to add to, I would like to add exception close to existing to being here. Okay, so basically if I got a boolean which is the primitive type and not the wrapper, this will be in here, and I will still be able to identify that's a primary type, primitive one. I have to do the same with byte, with short, okay, with integer, with float, sorry for that, with float, double as well, and character as well. But basically, if we do that, we will have all the support we need, and we won't have an exception anymore if we use primary types. If I run this again, let me clear this up. If I run this again, I get that it still works, but as you can see, I'm using a wrapper value and not the primary value in here, just because I need this to implement comparable, so to be able to compare. That's about all with this demo. Okay, so basically now our deep cloner is able to do its job.